Hi guys, this is my small video for that post about normal distributions. First of all, I give the definition of the density of standard normal. Here's the definition. And in the end, I'm going to show the definition of a general, of the density of a general normal variable, and you will see that that definition is much more complex. So, as I said in my post, the students don't need to remember this formula because uh, there are enough ways to visualize the graph and to find the required integrals and so on. So we start with this density, then we plot it. Here is the command for the plot, and this plot is contained in my post. Then next we plot the function which is required for the mean. We have to multiply the density by x and then plot the resulting function. Here is the plot of that function, and we can see that this area is above the x-axis, this area is below the x-axis, and by symmetry they exactly cancel out. The area to the right is the area to the left with a negative sign, so the total is equal to 0. And then here's the function required for variance. The density is multiplied by x squared, and then we plot this function, and as you see, this is a symmetric positive function, so the total area under the graph is twice the area under the graph to the right of the origin. Here we calculate the integral, define the integral required for variance. Here's the definition. The value of that integral is equal to 1/2. This is calculated by Mathematica. We don't need to worry about how this is calculated. In fact, this involves very high level math. And finally, the main uh, purpose of this video is a visualization of linear transformation. You can see here that the parameter mu, the mean, changes between -5 and +5, and sigma changes between 1 and 3. Okay, so first we can see what happens when mu changes. The density moves left and right. For the lowest value of mu, it is centered at -5, and for the highest value of mu, it is centered at 5. And then when we change sigma, as you see, the density becomes flatter, or it is more peaked like that. All right. And finally, here is the bad way to give normal distribution. More advanced book than AP Statistics, they define the density of the normal distribution with this equation, and as you can see, there are parameters mu and sigma, and believe me, nobody can extract the properties of this random variable from this representation. In higher level books, it is shown that if we define this density like that, then the mean will be equal to the mu which we have here, and the standard deviation will be equal to the sigma which we have here. All right. Thank you. Bye bye.